The James Webb Space Observatory has done it again. As time goes on and it discovers more and more about our space, it is fascinating how it manages to redefine virtually everything we thought we knew about space or defy any calculations made by scientists. Recently, the James Webb has detected an object that is 100 times larger than the Milky Way. How did it manage to discover such a structure, and what does this mean for humanity? Join us to explore a little bit more about it. The number of structures that have been discovered occupy a wide range of characteristics. After publishing its first photograph on July 11, 2022, the fascination they generated made it clear that we are just beginning to get to know our outer space. This, of course, means that it would have been only a matter of time before we found an object much larger than our own galaxy. Space seems to be replete with such comparisons. After all, in our galaxy, we have a planet larger than many suns, Jupiter, just as there are many moons of similar size to the Earth. Back to the main topic and today's main protagonist, let's talk about the strange Alenia galaxy. This is a radio galaxy, a type of galaxy that is very luminous in radio frequencies. These radio frequencies span a particularly broad spectrum with wavelengths ranging from 10 MHz to 100 GHz. Although the James Webb Space Telescope has not yet studied this imposing galaxy in depth, it is hoped that it will soon shed light on the mysteries it conceals. Alenia is located 3.5 billion light-years away from our galaxy. According to several scientists, this galaxy is one of the strangest things ever found in our universe. The beginning of its history is complicated in itself. This massive and imposing galaxy was discovered by accident in what has been catalogued as a great stroke of luck. Estimates made by scientists indicate that this galaxy would rank as the largest known galactic structure in our universe. To understand this a little better, it is necessary to note that, as a general rule, radio galaxies have a massive black hole at their center. As it draws matter into its interior, it ejects radio jets to opposite sides of the nucleus of the galaxy itself. This process ends up generating a large amount of loose particles in space, particles that end up forming part of the creation of new stars and planets. Simply put, the galaxy is an ecosystem in itself where a constant cycle of creation and destruction is repeated and respected. At the time Alenia was discovered by a group of scientists using the Low-Frequency Telescope Array, or LOFAR. This is an array of variable-frequency telescopes spread across Europe. Although the existence of Alenia had been suspected for some time, confirming its presence had proven to be much more challenging than expected, especially since its columns were faint. However, years of observation facilitated its discovery as scientists reprocessed all the information they had about the galaxy, discovering new and interesting patterns that eventually formed the final pieces to find Alenia's size. This methodology is relatively popular, being used on several occasions to prove or disprove the existence of other galaxies. The case of Alenia is particularly interesting and curious largely because of its size. This factor has generated many doubts over time, considering that there is no reliable explanation to explain how it managed to reach its size. Throughout the video, we have mentioned that this galaxy is considerably larger than the Milky Way, but how massive is it really? It is necessary to understand that galaxies, as well as planets and stars, are measured from one point of view, that of the Earth. The only way to estimate the size of a galaxy is by observing astronomical images captured by a space observatory from its point of view. Based on several reference values, it was possible to accurately measure the wingspan of Alenia, which is located at 16 million light-years. Although this number alone seems surprising, it turns out that the size of this galaxy is equivalent to 100 times the length of the Milky Way. Here we must take a moment and weigh our knowledge, especially about this particular type of galaxy. Radio galaxies, a unique category within the vast spectrum of galactic forms, continue to intrigue scientists due to their distinct characteristics and behaviors. To date, there are approximately 1,000 radio galaxies known to exist. These galaxies are notable for their intense radio wave emissions, which are often linked to the presence of supermassive black holes at their centers. Among these 1,000 radio galaxies, only 10 of them are more than 10 million light-years across, making them extraordinarily rare and significant in the study of the universe. Alenia stands out even among this rarefied group due to its colossal size. With its immense scale and being located 3.5 billion light-years away, it presents an extraordinary sight. If this galaxy were visible to the naked eye, it would occupy the same space as our moon in the celestial vault, a testament to its staggering dimensions. This comparison helps us grasp the sheer scale of Alenia, highlighting how it dominates its section of the cosmos. The discovery of Alenia is of great scientific importance. It provides vital information about some of the filaments of our cosmic web, structures that are foundational to the architecture of the universe. These filaments, composed of dark matter and gas, form the scaffolding upon which galaxies are built. Despite their crucial role, they remain difficult to characterize and understand fully. Alenia's size and radio emissions offer a unique opportunity to study these elusive cosmic filaments. The data collected from Alenia could help scientists unravel the complexities of these structures, shedding light on how galaxies form and evolve over time. This knowledge is essential for advancing our understanding of the universe's large-scale structure and the fundamental processes that govern its behavior. The study of Alenia and similar radio galaxies not only expands our knowledge of these magnificent cosmic entities, but also provides critical insights into the underlying framework of the universe itself. Through these discoveries, we continue to piece together the intricate puzzle of our cosmos, one galaxy at a time. When talking about the cosmic web, we're basically talking about the building blocks of the universe, composed mainly of interconnected filaments and dark matter wound with gases on which galaxies will eventually be built. The clearest and most relevant example of these filaments would be the Great Wall of Hercules' boreal corona, which measures about 10 trillion light-years, hosting billions of galaxies. On the other hand, when talking about voids, it is necessary to mention the KBC void, as it is referred to. Its diameter is estimated to be around 2 billion light-years, and our galaxy is contained in this spatial region. Like the Milky Way, Alenia lies in its own filament. Its columns experience a kind of headwind as it moves through the medium. This subtle change affects its trajectory and the way its columns move, which seem to perform something resembling a rather slow dance. Much speculation has been made about its size. Some theorize that its impressive size, which seems to defy physics itself, is due to the fact that this galaxy was born from a black hole. Although this is a possibility that seemed viable, it was proven incorrect. A curiosity linked to the beginning of the galaxy is that in all this extension, no moons have been found. It is important to note that moons are quite common throughout our universe, so the total lack of moons in an entire galaxy could imply or provide clues about its origin. Theories explain that the lack of moons is not because they do not exist, but because it has proven to be extremely difficult to explore this galaxy. It is expected that over the next few years or even months, the James Webb will be able to provide the necessary information to clarify the mysteries hidden in this galaxy. In addition, astronomers have pointed out that this galaxy is in constant expansion. As a consequence, Alenia is a region with a lower density than the average in which it is located. Scientists who are part of the group that found Alenia commented that beyond the geometry, Alenia and its host are suspiciously ordinary. The total low-frequency luminosity, density, stellar mass, and supermassive black hole mass are lower than but similar to those of the median giant radio galaxies. Only time will dictate the fate or what we will be able to discover about the galaxy, which could hide in its imposing size secrets that will allow us to learn a little bit more about how our universe works and the cycles it goes through. We invite you to subscribe to the channel and activate the notification bell to keep up to date with our new releases, where we discover some of the secrets hidden in the vast solitude of space. That's all for today. If you like the video, please like it. See you soon.